we developed an experimental research microprocessor containing the most Intel architecture cores ever integrated on one silicon chip.
The SEC, or the single-chip cloud computer, was designed as a concept vehicle for parallel software research.
On a single piece of silicon, it implements message passing technology, which resembles data centers or supercomputer on a single chip. This represents the latest achievement from Intel's Terascale research initiative, and this was co-led by Intel Labs in US, Intel Labs Germany, and Intel Labs Bangalore.
The single-chip cloud computer was designed as a concept vehicle for parallel software research. We believe this is an ideal hardware platform to advance many software research and development. We have the single piece of silicon that resembles a cluster of compute nodes, which can communicate with another compute node via a communication network that is packet-based.
In Braunschweig, we did the logic design of the core, where we took a small IA core and adapted it for the needs of the project. We designed the logic and circuits of the streamlined energy-efficient memory controller optimized for a many-core architecture.
The researchers in India led the circuit and physical design of the IA core, the memory controller digital portion, and the on-die mesh network. This included implementing synthesis and custom design in Intel's 45-nanometer technology, as well as validating and doing the performance verification of this large chip.
Finally, we own the development of the system platform, including the board firmware. You can see the board in action here. As you can see, this is not a standard motherboard, but it's an experimental platform to allow easy access to various signals for all the research we intend to do with it. We also developed a Linux operating system for this platform based on a full-featured standard Linux kernel, where we applied the necessary changes for the specifics of this experimental platform.
We are going to demonstrate a variety of applications ported to this single chip cloud computer. The applications such as web servers, data informatics, as well as bioinformatics and financial analytics. These are some of the applications which are the key applications which take advantage of a single chip cloud computer.
Combined with other interesting experimental features, this prototype opens up a lot of exciting research vectors. Our key motivation is to experiment with this architecture to improve parallel software programming for hundreds and more cores.
From a programmer's perspective, this chip is going to be just fascinating because it has a rich memory architecture. And I think that's really going to be what we will do with the chip, is we will explore different memory architectures than our standard multi-core line and how that impacts the programming models. We're exploring low latency message passing models, which will allow us to move these cluster applications and move them onto the chip and explore and what flexibility we have in the algorithms given that very low latency.
This new research processor has got many innovations for scalability and energy efficiency in the form of improved core-to-core communications as well as advanced power management techniques. Now, these innovations will enable software to innovate and throttle the power anywhere from the peak 125 watts to 25 watts.
We see parallel programming productivity and power management as two areas that need to be improved in order to take benefit of so many cores. This microprocessor we introduced today will help us perform groundbreaking research in those domains.
We plan to share this platform with not only our internal partners at Intel, but we would like to also share this with external partners, industry partners, as well as academia partners, to enable them to do their parallel programming research in a much more efficient manner.